Kia ora Year 12. I'm working backwards through the school exam for stats. This is question 5. I've just done question 7. So this one you were mostly pretty confident with, but there are a few things in here to watch out for. It's using a PDF for a continuous random variable to find probabilities. One place where lots of you missed out was on drawing the PDF. There's just one wee thing we've got to watch out for. And the last question was a problem-solving one. Okay, so we're given a random variable t, and that gives us the time in seconds for which a firework burns before it explodes. And this is the PDF. Things to note for when I'm going to draw it. Between 0 and 5, the function is going to be above 0. But in other places, it's going to be 0. And when we draw the graph, we have to make sure that we show this. Okay, so just to be complete. The first thing we've got to do is find the value of the constant. Then we have to sketch it. And then we have to solve this problem. And if you've got your graph right, I think it makes this question much easier. So the first thing we know is that because it's a probability density function, the area under the curve has to be 1. So we're solving the following equation. Between 0 and 5, the area under the curve equals 1, gives me the following integral. I'm going to have 5e to the 0.2t, evaluated at 5 and 0, equals 1. Lots of different ways to do this, but this is probably the cleanest. Now, substituting in, we get, let's see, we get e to the power of 1 minus 1, right, so that's substituting in 0 there, is equal to 1 over 5k. And that 5k is by dividing both sides through by 5k. That gives me e minus 1. So k times e minus 1 is equal to 1/5. K is equal to 1 over 5 times e minus 1. And that's what we had to prove. So that's the first part done. Now let's have a look at how we're going to sketch the graph. We can see that it's an exponential. We don't have to put numbers on, but I think it's probably safest if you do work out a couple of endpoints. So f at 0 is going to equal 1 over 5. Oops, let's just turn that off. Sorry about that. Right, so it's 1 over 5e minus 1 times e to the power of 0. So that's equal to 0.1164. And f of 5 is going to equal 1/5 times e minus 1 times e to the power of 0.2 times 5, which is 1. So that gives me 0.316. So your graph needs to look something like this. Right, don't forget to take your ruler into the exam. Here's my starting point. So we're going to wash it up like that. But then on here, we're just going to show that it's 0 when we're not in those ranges. Oops. Okay, well, you've got the idea, right? Now that I've made a big mess, there, it should look like that. So that point there is 0.316, and that point's 0.116. And that's x, and that's f of x. There, that looks better. Right, now let's have a look at the last question. Because if we can shade in an area, it's going to make it very easy. 80% of fireworks burn for longer than a certain time before they explode. Find this time. Now, if you work too fast, what you're going to do is you're going to put in 0.8 as the area we're trying to find. But what we're looking for is to say that if we've got 80% longer than a certain time, we want this area to be 0.8. The easiest way to do this problem is to solve for this area here being 0.2. So there are two ways to go here. We can find the integral between x and 0 equaling 0.2, or we can find the integral between 5 and x equaling 0.8. But you're going to have to do a little bit more work for that one. So I'm going to do it this way here. Right, what have we got? Well, we've got 1 over 5 times e minus 1 the integral between x and 0 of e to the 0.2t dt, and that has to equal 0.2. So I'm going to multiply through by the constant, and I get 5e to the 0.2t between x and 0 is equal to 0.2 times 5 times e minus 1, which is just e minus 1. Substituting in, we get 5 times e to the 0.2x minus 5 equals e minus 1. Now, there were quite a few mistakes made in the next part by people who mucked up their log rules. So just don't go too quickly, because you saw in class today what happens when you do that, right? We get e to the 0.2x is equal to this. I wouldn't get my calculator out just yet. Now I'm going to take logs of both sides. So 0.2 of x is equal to the natural log of this. So x is equal to 5 times this. And when you work all that through, it ends up being 1.48 seconds to 3 significant figures. So there you go. I think that's quite a nice question, because this last bit here about the 80% of fireworks really makes you think about the graph that you've drawn in part 2. Most students did pretty well with that question, especially part 1, and most people lost a mark in part 2, which is because I hadn't hammered into your brains quite well enough that you have to show the 0 region. And then most of you mucked up this last part about the 80%. So definitely a question that's worth going over in the next couple of weeks.